In this video, we're going to learn about the FiveNumber Summary and Boxplots. So we explored data to see if they contain any interesting information that may be useful in our research. So remember, we either pose a research question and collect data, or we have data and we want to learn about what it says. And so we explore the data in both those situations. The summaries we've studied make this exploration much easier. So a lot of the things that we've learned so far. So in fact, because these summaries represent an exploration, a famous statistician named John Tukey called this material exploratory data analysis. So the first thing we're going to do is compute what's called the FiveNumber Summary. The FiveNumber Summary of a set of data consists of the following: the smallest data value, quartile 1, the median, quartile 3, and the largest data value. So those are the 5 parts to it. We organize the FiveNumber Summary as follows. We have the minimum, quartile 1, median, quartile 3, maximum. So the data in this table shows the finishing times in minutes of men in the 60 to 64-year-old age group in a 5-kilometer race. Determine the FiveNumber Summary of the data. So we have observations for this event. So let's see if we can get those 5 values. So if we first write the data in ascending order, notice some of the things we need right away is the smallest value and the largest value. So the fastest time in this case is the smallest number, 19.95. And the largest number is the slowest time, essentially, the 54.63. So we've computed these in the past, but the median, remember that would be the middle value. Since this is in ascending order, we can find that middle value. And then quartile 1 is the middle or median of the lower half of the data. So the data less than the median. And then quartile 3 is the middle of the upper half of the data. Okay, the middle of those numbers. And so we have these 5 numbers, which represent our FiveNumber Summary. We're going to use software now, or a graphing calculator, to determine the FiveNumber Summary. So we can use Minitab. I'm going to go ahead and pull us over to StatCrunch, and we'll do it over there. Okay, so I've entered the data set into StatCrunch, and now what I'm going to do is I'm going to go to Stat, Summary Stats, and columns, because our data is in a column. So I want the time column, and I'm going to select the 5 values for our FiveNumber Summary in order. So the first one was the minimum, so I'm going to select minimum, and then I'm going to hold down Control on my keyboard, and the next number we want is quartile 1. Okay, I'm letting go of Control when I scroll, and then I need the median next, so Control, click median. Then we want Control, click quartile 3, and last Control, click max. And there is our FiveNumber Summary. The min, quartile 1, median, quartile 3, and the max. The next thing we're going to talk about is how to draw and interpret box plots. So here's some steps for this. First, step 1, determine the lower and upper fences. We've talked about this before, but the calculations for you involve the inner quartile range. If you recall that that's just quartile 3 minus quartile 1. And for the lower fence, you say your quartile 1 minus 1.5 times the inner quartile range. And then for the upper fence, quartile 3 plus 1.5 times the inner quartile range. So that's step 1. Step 2 is to draw a number line that's just long enough to include the maximum and minimum values from your data. And then what you're going to do is draw vertical lines at 3 places: your quartile 1 value, your median value, and then your quartile 3 value. And then once you draw those 3 lines, you close them in to form a box. Then label the upper and lower fences. Next, what we're going to do is draw a line from the quartile 1 to the smallest data value toward the left, as long as it's larger than the lower fence. And then on the other side, we're going to draw a line from the quartile 3 to the largest data value as long as it's smaller than the upper fence. And then we call these two lines whiskers. Then step 5 is if any data values are outside of what we pretty much drew, lower than the lower fence or greater than the upper fence, then we put an asterisk to denote that. So let's try this out. We're going to use the results from our previous example from that 5-kilometer race to draw a box plot. So we've already done some of these calculations. We know that quartile 1 is 26.06, the median is 30.95, and quartile 3 is 37.24. So the interquartile range, which we're going to need for our calculation, is just Q3 minus Q1, so that's going to be 11.18. A way to interpret this value is just to say that the difference between the 75th percentile and the 25th percentile is a time of 11.18 minutes. If you recall, the 75th percentile is your third quartile, and the 25th percentile is your first quartile. So pretty much 50% of the data is within 11.18 minutes of each other. So we're going to compute the lower and upper fences using our calculations. So notice we just plugged in our interquartile range value, and we plugged in our Q1 and Q3 values. And then just remember, you need to multiply before you add or subtract. So do the 1.5 times this IQR first, then subtract, and then add. And so we got our lower fence value at 9.29. The upper fence is 54.01. Now we're going to draw our horizontal number line, and we want it to encompass our data values. And so if you recall, our largest data value was in the 50s, so we can draw a number line going from 0 to 60, and it will cover all of our data values. Then the vertical lines are drawn at Q1, the median, and Q3, and then you just close them in to form a box. And so you can label the axis down here with more numbers if it helps, but notice that Q1 is above roughly the spot where 26 would be, 26.06. Q3 is above on the number line where 37 would be, and then the median is right past 30, which is because it's 30.95. Now we're going to temporarily draw the fences. So the lower fence value was 9 point something, so notice it's just like right before the 10. The upper fence was 50 point something, I think 54 point something, and so it's right here between 50 and 60. And then we're going to use those to draw what we call the whiskers. So starting at the quartile 1 value, which is the left side of your box, you're going to draw a line toward the left. And where you draw it to is the smallest number in your data set that's on the right side of this fence. So the smallest number in your data that's still larger than the lower fence value. And so because our lower fence was 9.29, our closest number to that on our data set was like 19 point something. So that's where we draw this to. This is about 19, I think, 0.95 maybe, if I remember the number correct. Very similar on the other side. For the other whisker, from quartile 3, you draw a whisker toward the right to the biggest number over here in your data set, as long as it's less than your upper fence. So our upper fence was 54.01, and so the number closest to that in our data set that was less than that was actually 49.17. So we draw a whisker from the right side of our box, which is quartile 3, to that data point. And then the last step is to draw any outliers. In this case, there was one. There's no numbers in our data set less than the lower fence, but there was a number greater than the upper fence. It was that 54.63. So that number was past our upper fence, so it didn't get included with the whisker, and so we put an asterisk right where that would be. And so that is a box plot. Now we can look at box plots and compare them to histograms and then talk about how our data is distributed. So if you take a look at the three examples here, the first one is skewed right. The middle one is nice and symmetric. It's actually bell-shaped. And then this other one on the right side, this is skewed left. And now look at the corresponding box plots. When your histogram would be skewed right, so is your box plot in terms of the whisker. This whisker on the right side is much longer. Over here, if your data is skewed left, the box plot whisker on the left is much longer. And then if your data is symmetric, then the whiskers are about equal on both sides. So the previous example suggests, based on our box plot, that our distribution is skewed right, and that's because the right whisker was longer than the left whisker when we drew it. What that means is that the median is left of the center of the box. So let me just clarify that real quick. Let's draw it here. If you look at this box, this one is skewed right like ours was. The center of the box is like maybe right here. And so the median, if I can draw a line down, let's say that's the center of the box, the median is to the left of it. Okay, and that happens when our distribution is skewed right. So now let's look at this one. In the Space Lab Life Sciences 2, led by Paul Callahan, 14 male rats were sent to space. The red blood cell mass of the rats was determined when they returned. A control group of 14 male rats was held under the same conditions except for spaceflight, as the space rats were, and their red blood cell mass was also measured when the space rats returned. The data here in this table is from that experiment. So we're going to construct side-by-side box plots for red blood cell mass for the rats that went to space and then the control group. And then we want to determine, does it appear that the space flight affected the rat's red blood cell mass? Okay, so using the data, here's the two box plots for the control group and then the group that went to space, the flight group. So the figure shows the side-by-side box plots, and you can create these in StatCrunch. We'll go ahead and go over there in just a minute. And what happens is it appears that the space flight has actually reduced the red blood cell mass of the rats, and that's because the median for this flight group is less than the median for the control group. Okay, so when you compare them side by side like this, you can see, and then if you also want to make sure that's on the same number line, you can see how they compare to each other. Okay, so I'm in StatCrunch and I've inputted the data from the rats and the two different groups. I just put them in two different columns. So we have the ones that went to space, the ones that didn't go to space, and now all we have to do is go to graph, and we want Boxplot, and I want both of these columns because I want to do a side-by-side comparison. So I just hit shift and click on both of them. And we've been drawing our boxes horizontally, so I'm going to click that. And I'm going to go ahead and label where the median is and compute. Okay, and there is our box plots. Let's just spread them out. And notice that the number line is just so long because we do have this one outlier over here. And so we have the ones that went to space, the ones that didn't go to space, and the left side of the box is the first quartile, the right side of the box is third quartile, and then where the red line is, it would be our median. All right, that's it for this one. Thanks for watching.